Good morning, everyone. Welcome to our webinar on temperature and pressure ratings. We have 90 people joining us today. My name is Braidlin McEwen, and I am the social media and content coordinator here at Beauchart Industries. Due to COVID-19, my team and I are all at home, but Will Bender, our quality assurance analyst, Steve Hudson, our quality assurance manager, and Paul Erb, our research and development manager, will be available to help answer any questions at the end of the presentation. Any questions we cannot get to, we will reach out after the presentation. Throughout the presentation, you can type out any questions that you have. You should see a sidebar on the right-hand side of your screen. If you click on the top button, which looks like an arrow in a box, it will open up a little menu with a question box, which you can type your questions and we will be able to see them. Please note the slide number if you're referencing a specific slide. The numbers will be displayed on the bottom left of the slide. To begin the presentation, we will go over exactly what temperature and pressure ratings are, then go into how they apply to malleable fittings. We will then take a look at some different scenarios, then move to ball valves, where we explore how temperature and pressure ratings work with ball valves, followed by some more scenarios. To finish the presentation off, we will have two quick scenario quizzes. You will be able to type out your answer to the question in the question bar, and any correct answers will be put into a draw to win a prize. We will then finish with any questions regarding the presentation. Let's get started. First, we will take a look at temperature and pressure ratings. A good rule of thumb to always keep in mind is when the pressure rating goes up, the temperature goes down. And when the temperature goes up, the pressure rating goes down. This statement is true for all pressure vessels, including valves, fittings, and pipe. Temperature is the final factor in determining the pressure rating of valves and fittings. Because metals are weaker at higher temperatures for any given material, pressure ratings decrease as temperature increases. The malleable pressure rating is determined by the max pressure at the highest operating temperature. The ball valve pressure rating is determined by the max pressure at the lowest operating temperature. It may look like the ball valves are rated so much higher at 600 psi and the malleable is rated lower at 150 or 300 psi, but in reality, they are much closer than you would think if you look at the standards to which they are rated. To break it down and make it easier, we have created some scenarios to help you better understand. Let's now take a closer look at temperature and pressure ratings for malleable fittings. The important thing to remember when working with malleable fittings is that the malleable fittings pressure is rated at the highest temperature. For years, we referred to fittings as 150 or 300 pound. In 1973, the term pound was changed to class. Speaking in terms of pounds or PSI causes confusion and should be avoided. Fittings should be strictly referred to by the class number. Here are some examples of stainless, bronze, and black malleable fittings. These two pictures show the difference between a class 150 fitting and a class 300 fitting. As you can see, the wall thickness is significantly thicker on the class 300 fitting. The pressure rating solely depends on the temperature of the media. Class refers to the maximum pressure at the highest allowable temperature. The allowable working pressures for pipe nipples are derived from ASME B31.3 Process Piping Code. Considerations were taken into account for the wall thickness material removed by threading. Each component must be checked to verify its suitability for the system. The amount of wall thickness lost due to threading an NPT thread on Schedule 40 pipe can be up to 50%. As operating temperature increases, a heavier schedule pipe nipple may be needed to meet the system design requirements. For this webinar, we are going to focus on malleable fittings and ball valves. However, the same principles apply to pipe and pipe nipples. Class 300 fittings pressure rating charts have reduced pressures for different nominal sizes. For example, a 1-inch fitting is rated at 2000 psi, double the rating for a 3-inch fitting at the same temperature. Pressure rating reductions for larger ball valves is also the norm. For example, our 0827 series ball valves are described as a 600 CWP rated valve. However, you will see a notation indicating that the 2.5-inch and larger valves are rated at a lower 400 CWP rating. This is an example from a chart that we will have available in a downloadable PDF following the presentation. These charts are to be used as a reference guide only. Specifying the correct pipe schedule and pressure class of a fitting depends on many different factors. It is the ultimate responsibility of the end user's piping engineer to specify the correct pipe schedule and pressure class of fitting that will safely work in its intended application. We will now move on to some malleable fitting scenarios. Here is our first scenario for malleable fittings. This example is of a system with a maximum operating pressure of 200 psi non-shock with a maximum media temperature of 300 degrees Fahrenheit, 149 degrees Celsius. What class fitting does the system require? A class 150 or class 300? Let's take a look at the pressure temperature chart to determine which class fitting is acceptable for this particular application. This chart is designed to help determine which class fitting will work based on the temperature and pressure of the system. The first column shows the temperatures, the second column shows the class 150 fitting and the pressure ratings, and the third column shows the class 300 fitting and the pressure. So now that we have all the information, we can figure out what class fitting the installer requires using this chart. First, we will look for the temperature, which is 300 degrees Fahrenheit, 149 degrees Celsius. Since the class 150 fitting is rated with a pressure of 150 psi, this particular system will require a class 300 fitting. For our second scenario for malleable fittings, we will take a look at an example of a system with a maximum operating pressure of 300 psi non-shock with a maximum media temperature of 100 degrees Fahrenheit, 38 degrees Celsius. Do you think a class 150 fitting is acceptable, or do you think the system designer will need to select a class 300 fitting? Since the system has a maximum operating temperature of 100 degrees Fahrenheit, 38 degrees Celsius, we first find the applicable temperature range in the first column, then follow across to the right to verify the pressure. Under the class 150 column, you will find 300 psi, confirming that the class 150 fitting is suitable for this system. If the installer were to select a class 300 fitting, it would be overkill as the system does not require a fitting that can handle 1000, 1500, or 2000 psi. Now that we've taken a look at malleable fittings, let's move on to ball valves. Throughout the presentation, we will only be talking about 0825 ball valves. Ball valve pressure ratings are rated at the lowest temperature industry-wide. This applies to all the Bochart ball valves with the BII identification logo, which stands for Bochart Industries, Inc. We will walk through a couple of ball valve scenarios looking at the Bochart 0825 series. It is important to note that there is not an industry temperature pressure derating chart for valves. You must obtain the chart from the manufacturer. Let's move on to some ball valve scenarios. As you can see in the picture, the system has a maximum operating pressure of 600 psi non-shock and a maximum operating temperature of 100 degrees Fahrenheit, 38 degrees Celsius. Let's take a look at the chart to figure it out. Do you think the 0825 no lead series ball valve will be acceptable? This chart shows the working pressure, PSI, on the left, and it shows the temperature in Fahrenheit at the bottom. The gray shaded area represents the area on the chart that would be accepted. Based on this chart, the 0825 series ball valve is rated 600 psi, well beyond the 100-degree Fahrenheit temperature, making it acceptable for this system. You will notice that the pressure rating does not drop until somewhere between the 212-degree Fahrenheit and 248 degrees Fahrenheit, at which the pressure rating drops at a significant rate as the temperature increases. The last scenario we're going to look at is a system including both malleable fittings and ball valves. This system has a maximum operating pressure of 200 psi non-shock and a maximum operating temperature of 300 degrees Fahrenheit, 149 degrees Celsius. What class fitting is required for the system? Will the 0825 NL series ball valve be suitable? First, let's figure out what class fitting the system requires. Based on the 300 degrees Fahrenheit operating temperature, you are required to use a class 300 fitting, as the class 150 fitting at 300 degrees Fahrenheit is limited to 150 psi, where this system requires 200 psi. Based on the system's maximum operating pressure at 200 psi non-shock and a maximum operating temperature of 300 degrees Fahrenheit, 149 degrees Celsius, the 0825 series ball valve falls within the allowable range and is suitable for this specific system. Altogether, the class 300 fitting will be needed for the system, and the 0825 series ball valve will be a perfect fit. If you have any questions based on any of the scenarios we have gone over, feel free to ask them now, and we will try and get to as many as we can at the end of the presentation. If your question is for a specific scenario, please include the slide number. The most important thing to remember is that when it comes to temperature and pressure ratings, malleable fittings and ball valves are opposite. Malleable fittings pressure is rated at the highest temperature, and ball valves pressure is rated at the lowest temperature. As operating temperatures rise, the pressure rating may start to fall. As nominal component size diameter increases, the pressure rating will possibly start to fall. Bochart does not specify what products are suitable for a given system. The selection of appropriate valves, fittings, and nipples must be determined by a qualified system designer or engineer. We will now move on to the quiz section of the presentation. You can type out your answer in the question bar, and any correct answers will be entered into a draw to win some cool Bochart swag. Please include the quiz number along with your answer when answering. If you have won, we will contact you following the presentation. Here is the first quiz. If an installer is creating a system that will run at a non-shock pressure of 250 psi and 250 degrees Fahrenheit, 121 degrees Celsius, can they use a class 150 malleable fitting? Let's take a look at the chart to figure out the answer. I will give you a minute to look at this chart and type out your answers. The correct answer is no. At 250 degrees Fahrenheit, 121 degrees Celsius, The max pressure rating for class 150 is 185 psi. For the final quiz, here is an example of an application that runs at 150 psi non-shock at an operating temperature of 300 degrees Fahrenheit, 149 degrees Celsius. Can a class 150 fitting and a Boschart series 0825 no lead ball valve be used? Let's take a look at both the malleable and ball valve chart to get the answer. Here's the malleable fitting chart to help you determine if the class 150 fitting will work for this application. I will give you a minute to look, then we will move on to the ball valve chart. The answer is yes, the class 150 fitting will work for this particular system. Now I will give you another minute to see if the 0825 no lead series ball valve will work with this particular application. The answer is yes. Both the class 150 and 0825 series ball valve will work with this application. Thank you to everyone who answered. Everyone who got the answers correct on both quizzes will be entered into a draw, and we will contact the winners after the presentation. We will now take the time to answer any of your questions that came up during the presentation. Any questions we cannot get to, we will address after the presentation. One question did come in here during the presentation and was answered by one of our tech guys. The question was, you mentioned on slide 14 that your pipe nipples are manufactured from grade B pipe. Are there higher quality grade A pipe nipples available? The answer is no. The difference between grade A and B pipe is not a quality issue, but rather the intended application. ASTM A53 grade B pipe is more popular than other grades of pipe. The grade designates mechanical properties such as minimum yield and tensile strengths. Grade B pipe is manufactured from steel, having a higher carbon content, resulting in higher tensile and yield strengths. Grade B, having higher stress values, is better suited for machining operations and is used for pipe nipples. Grade A pipe is a softer steel and typically used for special applications such as cold bending and close coiling, since it is much easier to bend. Okay, I got another question here, and this was answered by Paul. Can I run slightly over the published pressure rating of the valve? The answer is no. Operating pressure should be non-shock and within the limits listed in the pressure temperature chart found in the product data sheet. So another one here was answered by Will. The question is, what do you mean when you mention non-shock pressure rating? Non-shock pressure is the maximum pressure that a valve or fitting can be subjected to. If a system's pressure could potentially exceed the non-shock rating due to pressure surges or water hammer, the valve is not suitable. You will need to select a valve or fitting with a pressure rating which is over and above the anticipated surge pressure. This is a great question and warrants a more detailed follow-up after the presentation. Okay, so another one here. This is also answered by Will. The question is, with regards to the chart on slide 19, do I understand this correctly? If someone were to ask for malleable fittings rated for 300 psi, it could be a class 150 fitting? The answer is exactly. A class 150 fitting is rated for 300 psi as long as the operating temperature does not exceed 150 degrees Fahrenheit. A couple of years back, we had a customer lose a job quoting the more expensive heavy pattern class 300 malleable when the tender called for a malleable fitting rated for 300 psi. The winning tender had quoted the less expensive class 150 fitting since the operating temperature was less than 100 degrees Fahrenheit. If the description is in psi or pounds and does not clearly state the class, one needs to clarify the class to be sure the right fitting is being quoted. So another question that came in here is answered by Steve. And the question is, if the G designation gas in WOG refers only to any non-flammable gaseous fluids, does the O for oil cover petroleum products? The answer is the same applies as with gas designation, which does not imply a product suitability or third-party approval for use with flammable gases. Similarly, the O designation for oil does not imply a product suitability or third-party approval for use with any petroleum products. Okay, so it looks like that's all the time we have for questions today. Any questions we did not get to, we will answer following the presentation. That is the end of the presentation today. You can learn more about the features we offer at Beaucharts, as well as other useful information on plumbing and water well products. At Beauchart U, our goal is to equip you and your team with the knowledge you need to be more successful. We regularly publish new blogs and content that will help you become more comfortable and confident with our products. Be sure to follow Beauchart Industries on Instagram, LinkedIn, and Facebook to stay connected with us. Thank you again for joining us today. Check out our website for more products, specs, and subscribe to our blog to receive new content updates. Enjoy the rest of your day and stay safe.